Computers. These electronic gadgets that know nothing but zeros and ones have become a massive part of our daily lives. From popping reminders to playing videos, from creating applications to handling military functions. Computers have been very effective with whatever they are used for. From the 1800s till date, these machines have been constantly evolving, and it is now impossible to imagine our world without them. So let's take a peek at this evolution through a timeline. Starting with the very inception of programmable machine and modern computer, pacing towards the time when computers started to sit on our hands as iPhones and quantum computers breaking the whole game of zeros and ones. If we look back to around 2700 BC, when the abacus was created, it is said to be the first computer. But the kind of computation that resembles later centuries initiated with the concept of punch cards, which were brought in early 1800s by Joseph Marie Jacquard. Jacquard was a French weaver and merchant whose revolutionary invention, the Jacquard loom, sparked up many ideas in the computer field. This loom used a series of wooden punch cards that enabled unskilled worker to manufacture complex patterns in a smaller time frame. Threads passing over and under other threads form cloth. Depending on which thread passes over or under others determines the pattern on the cloth. The cards controlled this time-consuming task, hence simplifying the whole process. The cards were based on a binary methodology of hole or no hole to construct the pattern. A few years later, Charles Babbage, a brilliant young Englishman, used these punch cards for his machines. His engine exhibited many of the vital features found in our modern computers today. In 1832, he converted his drawing room to a showcase for only a part of his first difference engine, which was planned to calculate and tabulate polynomial functions automatically. This difference engine is the first complete design for an automatic calculating device. Had it been built, 25,000 parts that would be shared between the calculating region and the printer would be required and would weigh approximately 4 tons with a height of 8 feet. Charles then designed a superior machine known as the analytical engine, in which he was assisted by Ada Lovelace, sometimes known as the world's first programmer. The machine can be divided into 4 sections that are the input section where the punch cards were inserted, the output which used to be an analog printer, the store where the data was held for processing, and lastly the mill where processing and control mechanisms were set up. Soon after almost completing the design of the analytical engine by 1840, Babbage moved to create a second difference engine as an improvement of the original. This time the same computing power was obtained using a third of the parts. It could calculate numbers 31 digit long and could tabulate polynomials up to the 7th order. Except a few test models for specific working sections, none of the Babbage's designs were fully built in his lifetime. However, later on around the 1980s, work on a fully functional model of the difference engine 2 was started under the curator of computer Doron Swade and was completed in London by 2002. Let's hop on to the 20th century now to talk about another pioneer in computer science, Alan Turing. He did the earliest substantial work in the field of artificial intelligence. He expressed an abstract concept of computing machine that had unlimited memory with a scanner to traverse back and forth through the memory. The scanner acts based on the program stored in the memory in form of symbols, with the possibility that the machine could act on its own and improve its own program. This theoretical machine could solve any problem that can be described by simple instructions on the memory tape. Later during the Second World War, being the leading cryptanalyst at the Government Code and Cipher School in England, he was able to crack the complex enigma used to encrypt communication by the Germans using an electromechanical machine he designed, the Bombi, saving millions of lives. He was a remarkable man with more stories, few of which can be realized in his biopic, The Imitation Game. But we can't fail to look at the first electronic computer without belts and gears that came about when mathematician and physicist John Atanasoff looked for ways to solve system of partial differential equations automatically and worked with a graduate student, Clifford Berry. They developed the ABC, Atanasoff-Berry computer, that was capable of doing so using binary arithmetic. These were the times of war, and they showed the need for revolutionary inventions. one of which was the Eniac, Electronic Numeric Integrator and Computer, which was the first programmable digital computer built by the United States during the Second World War. The US Army faced a lot of trouble with the computation of firing tables for artillery. 176 people were assigned with this job with disk calculators, but it was just too slow. Finding Mauchly with his idea of using electronic means to speed things up was a jackpot, and it was funded in 1943. John Presper Eckert worked on this as a chief engineer and John Mauchly as his consultant. The machine had the ability to perform 5,000 additions per second, occupying a 15 by 9 meter basement. It had 40 panels placed in a U shape, each of which was of 0.6 by 0.6 by 2.4 meters. It also had 70,000 resistors, 10,000 capacitors, 17,000 vacuum tubes, 6,000 switches and 1,500 relays, and it evidently was a giant. In the end, however, the Eniac was completed just as the war ended and played no role there. Instead, its first task was to calculate for the construction of a hydrogen bomb. Speaking about vacuum tubes, we cannot forget to mention another invention that is crucial even today, the transistor. Compared to the vacuum tube, it is smaller, uses much less power, hence dissipates very little heat. So being much more elegant, they replaced the vacuum tubes. It was created first in 1947 at Bell Labs in New Jersey. William Shockley had been working on the theory of the device for about 10 years but was unable to build it. John Bardeen and Walter Britton came in to handle the engineering and completed it in just 2 years. What they had created was the point contact transistor, which Shockley later replaced by designing the superior bipolar transistor.